So now we're going to graph this example here. It looks significantly more challenging, but we'll see that with the systematic approach, we will have no problems solving it. We will have no problems graphing it, okay? Now again, obviously you guys might wonder why we're talking about graphing it, and it's because, when you graph them, I want you to develop that intuition so that you can be able to graph any trigonometric function that you see relatively quickly, whether you need a super detailed sketch or whether you just need to get a picture, an accurate picture more or less of where it belongs, and because that might have some importance to you. In any case, let's begin. So let's look at this here. The way I'm going to look at it is, first I want to put it into a form that's going to make it easier for us to understand. In other words, for me, I prefer to write it like this: y equals a sine, open parentheses, b, x minus c plus b. Plus d rather. Because I know if I write it like this, I'm going to be easily able to identify how much it deviates from the center of the oscillation with the amplitude. I'm going to be able to find out its period. I'm going to be able to find out its starting point. And I'm going to be able to find out how much it has been shifted up or down. Okay? So if we put it in this form, it'll be easy for us to establish the important aspects of this problem. So let me copy it down here first. Y equals 4 minus sine of 2x plus pi. Okay? Okay. So first of all, we have a problem. This minus is here, and we don't want that. We want to kind of put it like this, where we have a plus d and an a type of thing, right? So the way we're going to do that is, we know that we can look at subtraction as a minus b is equal to the a plus the opposite of b, right? So here we can see this as 4 plus the opposite of, in this case, the b is the sine of 2x plus pi, right? Once we've written it in this form, once we've written it as an addition, we can immediately use the commutative law of addition. Okay, if we have a plus b, that's the same thing as b plus a, right? So here I can write this as negative sine 2x plus pi plus the 4. We're in a much better place now, right? But are we where we want to be at? No. I want to pull this 2 out of this expression, right? Of the linear expression inside of the sine. So I have negative sine 2 times x plus pi over 2 plus 4. Now here, why is it x plus pi over 2? Because if I distribute this 2 in here, in this parentheses, I'll get 2x, which is what we have there, plus 2 times pi over 2. That's the pi. Okay? Now, is this identical to this? Not yet. Because here, I want to write it as a minus c. So I can write it as negative sine of 2x minus negative pi over 2. Okay? Plus, in this case, 4. Okay. Okay. If we look at it like this, then we can use our table from our original problem to figure out in which direction it's going to go. Horizontally, anyway. But so now let's talk about it. So this has amplitude 1, because if we have a negative in front of the sign, we know, just like in algebra, whenever we have negative x, that's the same thing as negative 1x. We just typically don't write the 1 there, but we know that that's what it means. So what's the absolute value of that a? If the a is negative 1, well, it's just 1. So our amplitude is 1. Our period. What is our period? Our period is 2 pi over the absolute value of b. In this case, our b is 2. So it's going to be 2 pi over 2, which is just pi. Okay? Now, our horizontal shift, let's just call it HS, just to save us some time. We know that because you could look at either way here. If we're looking at our table, we know that when we wrote it as x minus c, then it would be a shift to the right if c was positive and a shift to the left if c was negative. Okay, here we can see since the c is negative, it's going to be a shift to the left. So horizontal shift left by pi over 2. Alternatively, if you look at it like this, with the x plus pi over 2 on the inside, then we know it's going to be a shift to the left. Okay? Okay. Anyway, once you see a few examples, you'll memorize these rules. They'll make more sense. And if there's any doubt, you can always set the inside of the sine or the inside of the cosine equal to 0, and you'll see from what it gives you whether you want left or right and by how much. Okay? But it's good to remember these rules because they save a lot of time. So now we're going to look at the vertical shift. We can see that there's a plus 4 at the end of this. That means that it'll be vertically shifted up by 4 units. Okay? Okay. And remember, when we're going to make our table, we calculate the separation of the points. Okay? By taking the period. Okay? And we divide it by 4, like this. In this case, our period is pi, so our separation will be pi over 4. Okay? So let's make our table here. Okay? Okay. So, since we know it's a horizontal shift left by pi over 2, what's 0 minus pi over 2? Negative pi over 2. Right? Now, my separation is pi over 4. So I'm going to have to add pi over 4, pi over 4, pi over 4, pi over 4, 4 times to get our main points. Okay? Let's do that here in explicit detail. Okay? And let me just copy this over a little bit. So, let me first see here. So I'm going to start by summarizing our rewrite of the sine function so we can give us some room here to do this graph, okay? I mean to do this calculation. So we can both see it, so that we can all see it together. Okay, so here, let's do this together. So first of all, I want to fill out my table of points by adding the separation, as I mentioned, 4 times. So first I'm going to start with the first one. What is negative pi over 2 plus pi over 4? That's going to equal negative pi over 2 times something plus pi over 4. Now, as you guys might have already noticed, if I multiply 2 by 2, I get 4. So that's why I know here that I'm not going to have to multiply the pi over 4 by anything. I just have to multiply the pi over 2 by 2 over 2, and I'm done. I can see that that's going to give me negative 2 pi over 4, and then I bring my plus pi over 4. And if I have negative 2 pi over 4 plus pi over 4, that's going to be negative pi over 4. Like this. So now I'm going to add pi over 4 to this. You can see negative pi over 4 plus pi over 4, that's just 0. 0 plus pi over 4, that one's just pi over 4. And if I add pi over 4 again, I get 2 pi over 4. So in this case, these numbers, they came out super nicely. right? It's not always going to be like that, right? But here, we could see that it came out very nicely. So now what we're going to do is we're going to evaluate not the whole expression. We're going to evaluate just the sine part of the expression, okay? So in this case, what is the sine of 2x plus pi? Okay? Okay, let us delete all of this, okay? We don't really need any of this anymore. Right? Okay. So I'm going to now evaluate the sine of 2 pi over x at negative pi over 2. What is the sine of 2 times negative pi over 2 plus pi? Well, you can see that 2 times negative pi over 2 will be negative pi because the 2's will cancel. So this ends up being the sine of negative pi plus pi. Well, you can see here, negative pi plus pi, that's 0. So this ends up being the sine of 0. And the sine of 0 is just 0. It's always helpful to keep in mind your unit circle or to keep in mind the table of the parent function, right? Don't be afraid to draw them in the corner to double check yourself, right? Like if I have here, if I had my unit circle here drawn in, then what I could do is I could say, well, if I'm here, that's where the sine of the angle 0 will be, right? You see, it's an angle that hasn't opened at all, right? So you can see that the terminal side of the angle would be this point here, which has coordinates 1, 0, and which, because the sine is the y, the sine of the angle 0 would be 0. Okay? What about negative pi over 4? Let's plug in and find out. What is the sine of 2 times negative pi over 4 plus pi? Well, first we have to add this up. Okay? So this will be the sine of negative 2 pi over 4 plus, now, let me ask you guys a question. Is there any way I can write 1 as a fraction with 4 in the bottom? 4 over 4, right? So this can be seen as 4 over 4 times pi over 1. Okay? Then, of course, when you multiply that, you're going to get sine of negative 2 pi over 4 plus 4 pi over 4. And you can see that negative 2 pi over 4 plus 4 pi over 4 is 2 pi over 4. So that's sine of 2 pi over 4. What is that? That simplifies to sine of pi over 2, which is exactly what we want, because we can see that that's again one of the nice angles here, right? And we know that the coordinates of that point at the top of the unit circle, which correspond to the terminal side, which correspond to the intersection of the terminal side of the angle pi over 2 with the unit circle, the coordinates there are 0, 1. And since the sine is the y, that means that here, the sine of this value is exactly 1. Okay? Now, by the way, I also want you guys to notice, this means that we did the right thing, right? We can see that the angles are coming out exactly as they should from this procedure, right? So if I wanted to, I could just say, well, yes, so this would be 0, this would be negative 1, and this would be 0 again, right? Let's just plug in to make sure. Let's just double check here. So I'm going to plug in 0. What is the sine of 2 times 0 plus pi? We can see that what's 2 times 0? That's 0. What's 0 plus pi? That's pi. So this is in fact the sine of pi. Okay? You can see pi, the terminal side of pi will be here. And you can see that the coordinates are in fact negative 1 comma 0. And again, we can see that that is in fact, the sine anyway, is in fact 0 there, which is correct. Now we're going to plug in pi over 4, what is the sine of 2 times pi over 4 plus pi? Again, you can see that this will become the sine of 2 pi over 4 plus 4 pi over 4. Just as I did in the previous step, where I asked myself, I want to write pi as a fraction with 4 in the denominator. So I think, okay, pi over 1, because I can write any number as a fraction by sending it over 1. And then I multiply it by 4 over 4, because I know that if I multiply those denominators, I will get 4. Well, let me do it super technically here. Yes. So, can I write pi as a fraction with denominator 4? Right? And the answer is yes. As I mentioned, I will start with pi. And the first thing I do is I want to write it as a fraction. So I just set it as the numerator and set 1 as the denominator. Ta-da! It's a fraction now. But now I want it to have denominator 4. So what I need to do is I need to multiply it by a fraction that I need to multiply it by a fraction that equals 1, but that simultaneously will multiply with this denominator to give me 4. So I ask myself, what times 1 gives me 4? 4. Like this. So now I multiply the fractions. How do I multiply fractions? The product of fractions is the fraction whose numerator is the product of the numerators of the fractions being multiplied, and whose denominator is the product of the fractions being multiplied. So that's going to be 4 pi over 4. And that's how I know that to be fact. And of course from here, you can see that that's exactly sine of 6 pi over 4. And of course you can see that that simplifies to sine of 3 pi over 2. Right? Oh man, that's super ugly. Let me rewrite that for you. Yes. And by the way, I want you to notice the question that I had in my brain that I wrote out here explicitly, because I want you guys to think in terms of questions like that too when you're doing problems like this. Asking the right questions will help guide you. Of course, the 3 pi over 2, that's here. And you can see that here it's 0, negative 1. And so we indeed get, for the y coordinate, which is the sine, the negative 1. And then you can see here that this, the 2 pi over 4, let's do that here real quickly. I just want you guys to see how you can always double check, okay? So what is the sine of 2 times 2 pi over 4 plus pi? That's going to be the sine of 4 pi, oops, because 2 times 2 is 4 pi over 4 plus pi, and you can see what's 4 pi over 4? The 4's cancel, and I'm left with sine of pi plus pi. And what is that? That's going to be sine of 2 pi. And what is that? Well, we can see that that's coterminal with the 0, and that will have y coordinate. That terminal side that point where the 2 pi terminal side lands intersects with the unit circle at the point 1, 0, and hence has y coordinate 0, and hence has sine 0, and that's why it's 0 here. So we can see that we've gotten exactly what we wanted. We got all the angles that caused the sine portion of our original function to be a nice value. Okay. So now finally we're going to make our table where we've already taken advantage of. We've already calculated the sine value. We've done all the hard work now. Now we just plug it into our y. I'm going to do that here. Y equals 4 minus sine of 2x plus pi. Okay, look at this. This part is already done for us. All we have to do is literally 4 minus whatever this is. 4 minus 0 is 4 for this x value. 4 minus 1 is 3. 4 minus 0. 4 minus negative 1. That's 4 minus minus 1. That's 4 plus 1. 5. 4 minus 0. We have our y values. So now let us summarize these values and plot our graph. And again, I know I might sound like a broken record, but I want to look at my x's to see where I have to graph and look at my y's. You can see for my y's, I don't even go below 3. So I want to plot from 3 to 5 along the y's. For my x's, notice how here I'm symmetric with respect to the y-axis. I go to the front, to the positive side, pi over 2, because you can see 2 pi over 4 simplifies to pi over 2. And I go to the back, pi over 2. So here, I'm going to draw my x-axis more symmetrically in the middle. I'm going to draw my x-axis a lot lower so I can try to give like a more faithful representation of what's happening here. Say like this. So again, I'm going to label my angles underneath here so that it doesn't clutter where my graph of the function is going to be. And I'm going to label my y's over here, but you can already tell there's going to be 1, there's going to be 2, 3, 4, and 5, obviously. This is negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. Okay. Then here, 4. 3, 4, 5, and then 4. Okay, and the graph will therefore look like this. Okay. Now, let me show you something. If you notice, the center of oscillation is here at at y equals positive 4. And so whenever you see, for example, the vertical shift here being like, let's say, plus 4, that corresponds to where the center of oscillation has moved up or down. Okay? And then here, here you can see the amplitude, as we discussed earlier, of this function is going to be 1. And that's going to tell us the maximum deviation from the axis of oscillation to the graph itself. And you can see that occurs here, and it's 1 down, and here, 1 up, you see? So we can see that that's what the amplitude represents, how far from the angle of, how far from the axis of oscillation the graph goes in either direction. Okay. We noticed that the period was pi because we saw that the b was 2. We can see if we take this endpoint of the first period, pi over 2, and we subtract the negative pi over 2 that corresponds to the start of this period, we see that we get pi over 2 minus negative pi over 2 becomes pi over 2 plus pi over 2, which is exactly pi. That verifies what we had found earlier. And anyway, so here you have it. This is our graph. Okay. Let's just make a listing here of our important facts. Our domain, again, is negative infinity to infinity. You might want to graph it for some purpose, some practical purpose that might only be interesting in a certain range of x's. But from a mathematical point of view, this is the domain from negative infinity to infinity, where this pattern repeats forever to the left and to the right. Our range is going to be from 3 to 5. And our period, as we mentioned earlier, is pi for this one, as we calculated earlier. I hope you've enjoyed this example. Thank you so much. You're still there? You're watching this video? Well, I hope you enjoyed it. In any case, if you did enjoy it, well, I encourage you to like it. Put that big thumbs up there. And don't hesitate and don't forget to subscribe to my channel. And anyway, and also add a comment if you want me to cover up some particular topic. I can't make any promises. There's a huge list of topics I already want to cover, but time permitting, I may address that topic. And in any case, I hope you've enjoyed this video, and thank you again.